called Let There Be Light. There is my abstract and background information. So how glow-in-the-dark material works is basically you have incoming light coming in and hitting the electrons inside the material. The electrons then absorb this light and move up in energy level if the light has a high enough frequency. And when it moves up in energy level, it absorbs this energy from the photon and gains electric potential energy. Later, the electron goes down back to its ground state and then emits the excess energy as a photon. And that's the light we see when we turn off the lights. The importance of this research is that many emergency signs are made of glow-in-the-dark material. So if there's, let's say, a power outage, it's very important to make sure everyone knows where the exits are, where the fire extinguisher is, if a fire starts to happen. And it would be dangerous if the light being emitted wouldn't be adequate for the glow-in-the-dark material to work. So I chose to use visible light, of course, because UV rays are harmful for us, so that would be impractical. And infrared light is also impractical because you can't even see with it. So why would you have infrared bulbs all over? My hypothesis was that if I shine a red, green, blue, and white light of the same power output on glow-in-the-dark paint for the same duration, the white light will make the paint the brightest since it contains all visible light, including violet light, which has the highest frequency out of those colors. So I reasoned that E equals HF. So since violet has the highest frequency, the energy output would be the greatest. Here are my materials. There is the procedure. My variables, of course, independent variable is the color of the light. Dependent is the brightness. My control is using no light. Then we have my constants, my uncontrollable variables, and then I used a 4-color LED flashlight. Safety procedures is pretty simple. Just make sure when you're buying the paint, don't buy radioactive glow-in-the-dark paint. In the 1900s, they used to make it using radioactive material, but nowadays, I'm pretty sure they don't, but just in case, check to make sure it's not radioactive. For my execution, I photographed the brightness of each paint, after lighting it with the flashlight, I photographed the brightness and I compared it to each color of the light, each color light I used. And I used 3 different blocks of paint and I shined the light on each one. So there's 3 trials. And one adjustment I did make during the experiment was I originally was going to shine the light for 5 minutes each for 5 minutes on the cardboard, but I realized that after 30 seconds, it pretty much energizes the whole thing. So I stuck to 30 seconds. Here are my results. As you can see, the red light and green light was not able to produce any color into the glow-in-the-dark paint, and that is because green light and red light obviously does not have a high enough frequency to energize the electrons in the glow-in-the-dark paint, because you need one of the green frequency or higher to energize it. And I guess the green light I used was at a lower frequency than the green light that gets emitted by the glow-in-the-dark paint, which I thought was very interesting, which is why it had no effect. So my conclusion, it turns out that the blue light was actually the brightest, and I was very confused about this since I figured that violet light and the white light would produce the biggest output. But what I'm deducing is white light is not just composed of violet light, it's also composed of red light and orange light and yellow light. So perhaps the density of the violet light and the portion of the light that's high enough energy to energize the glow-in-the-dark material is let's say, we'll just make them a number, 50% of the white light can energize it, whereas 100% of the blue light can energize it. So then you have a difference in intensity. And since the blue light has more photons being emitted than the white light, the blue light would therefore create a greater glow. And here are my works cited.